Today's video is on properties of trapezoids. So a trapezoid is a quadrilateral. You can see that it has four sides. A trapezoid is not going to be a parallelogram though. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So the parallelograms that we've been talking about have exactly two pairs of parallel sides. Here our trapezoids only have one. All right, so in this example here, we have this top side and the bottom side. Those are going to be parallel. Now, each of those parallel sides are going to be called bases. So we have a base on the top here and a base on the bottom. Okay. The two non-parallel sides are called legs. So this is the first leg and that is the second leg. And then we have base angles. So our base angles are going to be two consecutive angles whose common side is the base. So if I look, I'm going to call this angle A and B. These two angles are next to each other and the side that they share is the base. So A and B, and then I'm going to call this pair X and Y. Those are our two pairs of base angles. So A and B. And then X and Y are the base angles in this trapezoid. Okay, so if we look at numbers 1 and 2, it says the quadrilateral below is a trapezoid and we want to solve for X. Now, it's giving us information about these two angles here. So I know this angle is 6x plus 20 and this angle is 4x. Now, these angles are consecutive angles, but they are not base angles because the common side that they share, if I kind of outline this angle here and this angle here, the common side that they share is a leg, not a base. So if I look back to my definition of trapezoids, I know that this side is parallel to this side. So I have my parallel sides, and then I can think of this leg here as being a transversal. Okay, so if I kind of outline it this way, all right, I have my two parallel sides and a transversal. So these angles that I highlighted in yellow are going to be my consecutive interior angles. And we know that consecutive interior angles are supplementary. So we can say the same thing here about our trapezoids, okay? So A plus X is going to equal 180 degrees. I'm going to write that up here. Oops, that's a time sign. So A plus X equals 180 degrees, and then we know B plus Y is going to equal 180 degrees because those are consecutive non-base angles. So if I wanted to solve for X here, I can set 6x plus 20 plus 4x equal to 180. I'm going to combine like terms and I get 10x equals 160, so x equals 16. Okay, same idea for number 2 here. So again, I have this pair of two angles. They are non-base angles, right? They're consecutive angles, but they are not base angles. So I see I have my parallel lines and my transversal. So I can set 15x minus 10 plus 6x plus 1 equal to 180. And combine like terms. So I have 21x minus 9 equals 180. Divide 21 by both sides and x equals 9. Okay. Now, in a trapezoid, we have a special segment called a midsegment. So the midsegment of a trapezoid is a segment that joins the midpoints of the legs of the trapezoid. The midsegment is parallel to each base. Okay, so here's my trapezoid. I have my bases. This midsegment here is going to be EF. So that is my midsegment. I'm going to abbreviate that. And it is going to be parallel to each of the bases. and it is formed by my midsegments of each leg. So E would be the midsegment of segment AB, so I know AE is congruent to BE, and F would be the midsegment of this leg CD, so CF would be congruent to FD. Now, if I wanted to find the length of that midsegment, I'm going to take the first base and add that to the second base and then divide by 2. So the length of the midsegment is going to be base 1 plus base 2 divided by 2. Okay? So in our next set of examples, it says to solve for x in each of the trapezoids below. So if I look at number 3, I see that this segment labeled x here is a midsegment because it is formed by this segment is created by 2 midpoints. So if I wanted to solve for x here, that midsegment is going to equal the sum of the 2 bases divided by 2. All right, so if I plug that into my calculator, 23 plus 37 is 60 divided by 2, and x equals 30. Now, number 4, 5, and 6 are all going to be very similar. All right, so my midsegment here is 7x minus 6. That's going to be equal to 22 plus 8 divided by 2. So here, I can just simplify the right side of this here. So 7x minus 6 equals, this is going to be 30 divided by 2, which is 15. And then I can solve for x. So 7x equals 21 and x equals 3. Okay. Now, if I look at number 5, I have the midsegment is 36. That's going to equal the sum of the 2 bases divided by 2. Okay. Now, for this problem, while I'm trying to clean up the right side to solve for x, I'm going to get rid of that 2 first. Okay, so anytime I have a number in my denominator, I want to cancel that out by multiplying. So I'm going to have 72 equals. And then if I clean up the numerator in that same step, I'm going to get 8x plus 8. Solve for x, 64 equals 8x. So x equals 8. Okay, and in our last one, again, that midsegment x is going to be equal to the sum of the 2 bases divided by 2. Multiply both sides by 2. And I'm going to clean up the numerator there to get 3x minus 5. Subtract 3x from both sides, negative x equals negative 5. So x equals 5. Okay. Now we're going to talk about special types of trapezoids called isosceles trapezoids. So we know an isosceles trapezoid, an isosceles triangle is a triangle with 2 congruent sides. And we have the same idea with isosceles trapezoids. So an isosceles trapezoid is going to be a trapezoid with congruent legs. So if I see here, my legs AB and CD are going to be congruent. Now, isosceles trapezoids are going to have more properties than a regular trapezoid. So the first is that the base angles of an isosceles trapezoid are congruent. So in this example here, angle B is congruent to angle C, and angle A is congruent to angle D. You still have that same property with the consecutive angles that are not base angles. So angle A plus angle B is still going to equal 180. But we just know that extra property of angles A and D being congruent and B and C being congruent. Okay, So again, if we know it's an isosceles triangle and AB and CD are congruent, then we know that angle B is congruent to angle C, and angle A is congruent to angle D. Now, the converse of that is if we have a trapezoid and we know that the base angles are congruent. So if I know that angle A is congruent to angle D, and I know that angle B is congruent to angle C, then I know that it is an isosceles trapezoid. Okay, so even though these two seem the same, it's really the information that we're starting with and we're concluding is different. So here we are starting with the fact that we know it's an isosceles trapezoid, so we know the base angles are congruent. And then here we're saying if the base angles are congruent, then it is an isosceles trapezoid, and segment AB is going to be congruent to segment CD. Okay, and then the last property of isosceles trapezoids are that the diagonals are congruent. Okay, so here segment AC would be congruent to segment BD. Okay, so those are our three properties for isosceles trapezoids that are not necessarily true about regular trapezoids. So let's take a look at these problems here and try to use these properties to solve for x or whatever measure it's asking us for. So if I look at number 7, it says solve for each variable. So I see that this is an isosceles trapezoid because my legs are marked as being congruent. My parallel sides here are actually the ones on the side, which looks a little bit different than the examples we've seen, but is totally fine. So I have, this is my base here, and I know this side is my second base. So if this angle right here that I'm highlighting in green is 113 degrees, then angle Z is also going to be 113 degrees because those are base angles. Now, if I wanted to solve for x and y, I know that the sum of those two angles have to equal 180. So x plus 113 equals 180. The measure of angle x there is 67 degrees. And again, because I have base angles, x and y are going to be congruent because those are base angles. So y is also going to be 67 degrees. Okay. If I look at number 8, it says solve for x. So again, I know this is an isosceles trapezoid because the directions are telling me that it's an isosceles trapezoid. But if I just saw that I had these parallel lines, I had these base angles being congruent, then I would know that these legs are congruent. So I can set 3x plus 1 equal to 5x minus 13 and solve for x. So I have 2x minus 13 equals 1, add 13 to both sides, and x is going to equal 7. Okay, number 9 is going to be similar to number 7. So I have isosceles trapezoids. I know the base angles are congruent. So I can set 2x plus 2 equal to x plus 18. Subtract x from both sides and subtract 2 from both sides. So x equals 16. And then for number 10, again, base angles are congruent. Have to be careful. This question is asking me to solve for the measure of angle W. So not just solving for x, but that is how I have to start. So I'm going to set 6x minus 6 equal to 4x plus 20. Subtract 4x from both sides. So 2x minus 6 equals 20. And add 6 to both sides. So x equals 13. Then I'm going to take that x equals 13 and substitute it into the measure of angle W. So 6 times 13 minus 6 is going to give me 78 minus 6, or 72 degrees. Okay. And then finally for number 11, I am looking at solving for x. It tells me that EG is 41 and FH is 7x plus 6. So those are my two diagonals. I know that diagonals are congruent, so I can set them equal. So I'm subtracting 6 from both sides. I have 7x equals 35. Divide both sides by 7. And x equals 5. Okay. And then number 12, I'm looking at my diagonals again. So JL is going to be 5x minus 3. MK is going to be 3x plus 19. So I can set them equal to each other. And solve for x. So I have 2x equals 22. X equals 11, but again, I need to be careful. I'm looking to solve for JL. So JL equals 5 times 11 minus 3, which is 52. So JL is 52. All right, so that is it for trapezoids and isosceles trapezoids. Thank you so much for watching. If you have any questions, you can comment them below. Thank you.